We've got here question five from June 2015. A group of learners uses the reaction of clean magnesium ribbon with dilute hydrochloric acid to investigate factors that influence reaction rate. The balance equation for the reaction is Mg plus 2HCl gives you MgCl2 plus H2 delta H is less than 0. Is this above reaction exothermic or endothermic? Give a reason for your answer. So let's write down in our books. First, question 5, rates of reactions, November. No, I said June 2015. June 2015, 5.1. The answer is endothermic or exothermic. How will we know? We'll have to look at the delta H of the sum. Delta H is less than 0. If delta H is less than 0, that means it's a negative value, so it is exothermic. So you'll write an answer. The answer will be exothermic. Give a reason for the answer. Delta H is less than 0. Okay. 5.2. In one of the experiments, 5 grams of magnesium ribbon was added to the hydrochloric acid solution. If 30 centimeters cube dilute hydrochloric acid solution of concentration 1,5 mole per dm cube is used up in 1 minute, calculate the average reaction rate in moles per second. So we have to calculate moles per second. So how are we going to do that? The rate of reaction is, how are we going to do that? Rates of reaction will be, are you writing concentration of change in concentration over change in time? All right, change in concentration over change in time. So that will be, what will the change in concentration be? The change in concentration is 1,5 mole per dm cube is your change in concentration, right? 1,5 mole per dm cube, and your time is 1 minute. So we must say this is mole dot s minus 1. So how do you find that? Let me find a memo. I must share a memo with you. Minute, you can't work in minutes, you must work in seconds now. So you'll have to change that to 60 seconds. Memo June 2015. All right, I'm going to show you the answer now. What answer did you get? Come on, wrong thing. 1 second. New share. I think this one is right. I'm learning a little bit. Okay. So depending on how you want to work, you can work out the concentration. I did the option 2, nah? 1,5 over 60, which is 0,5. So you change your first one, your average rate will be change in number of moles over change in second. So what they did, let's look at option 1 since we're working in option 1. Option 1, we can just take option 1 as a convenience. Number of moles equals to concentration times volume. Your concentration will be 1,5. Your volume will be 30 times 10 to the 3, which is, where did we get that from? They told us it is 30 centimeters cube, right? And then you got 0,05 moles, right? So then you can work in moles per change in number of moles over time. So then you get change in number of moles will be 0,045 moles. Why is it 0 minus 0,0045? Because it's final minus initial, right? And your time is 60, and you'll get 7,5 times 10 to the minus 4 mole per second. I did option 2, change in concentration over change in time. The change in concentration was 1,5 moles. All right. And then your change in time was 60, and then that gives you 0,025 mole per dm cube per second. But then to work out average rate, they say you can't use that. You must work out, you must get rid of the dm cube. So you multiply it by 30 times 10 to the minus 3. And then you'll get 7,5 times 10 to the minus 4. Okay, there's the other option. Is the third option here. If mass is used, the mass of magnesium used to calculate the number of moles of hydrochloric acid is equal to actual mass over molar mass. They said they gave you 5 grams now. So 5 over 24 is a molar mass, will give you 0,21 mole. So number of moles will be 0,21 over 60. which gives you 3,5 times 10 to the minus 3 moles per second. So that's another option that they allow. Okay, let me just put this, I must just share the right screen again for you. Okay, the right screen is on now, hopefully. You have the right screen on. All right. Question 5.3. The volume of hydrogen gas produced as a function of time in this experiment is represented by graph S. Okay, it's not graph S because it looks like an S now. The graph is not drawn to scale. How does the rate of the reaction change between, write down increase, decrease, or no change? T1 and T2. If you look at T1 and T2, if you work out look at the gradient of this graph here, right? Between T1 and T2, what can we say? Okay, let me just put a line rather. If you look here, for example, look at this gradient here. All right. And then if we choose another graph, let's choose another gradient. I don't know if it's going to write now. Look at the gradient there. What's happening? The gradient is quite large, all right? But it's getting a little smaller as time is going fast. Used to the collision theory, okay? So the question is, how does the rate of the reaction change between T1 and T2? From T1, you can just work out the gradient of the graph at T1 and T2. Let's just do that again. So at T1, what's your gradient? At T1, the gradient here, let's just take our gradient at T1. It's here, the steepness of the slope. All right. And then what's our gradient at T2? At T2, your gradient is there. So what happens to the steepness of the slope, the gradient? Between T1 and T2, use the collision theory. Between T1 and T2 in that whole area, what can we say? The rate of the reaction is quite large, but it slows down a little bit over time because the number of particles available for the reaction to form effective collisions is great. So basically, if you look at the next question, it says T2 and T3. Between T2 and T3, if I have to draw a graph here, look what's happening to the curve now. It's getting flat. So T1 to T2, the gradient is big, and T2 to T3, the gradient is getting smaller. So I think what it's telling you is, how does the rate of the reaction change between T1 and T2? You can say between T1 and T2, for question 5.2.2a, between T1 and T2, the gradient is large. The reaction is very vigorous. Vigorous, the right word. Yeah, the rate of reaction is fast, a fast rate of reaction. Vigorous, I think it's okay, because there are many particles available for effective collisions to take place. That will be T1 and T2. All right, there will be many effective collisions, and the concentration of reactants and products are greater. So there will be lots of effective collisions, and the reaction is quick, something to that effect. And T2 and T3, we see between T2 and T3, the reaction rate goes down. And the reason for that is the concentration of the reactants decreases. There's less effective collisions. So the particles there'll be less particles for effective collisions to take place. So the reaction slows down. All right, let's look at that answer there. One sec, let me get that share screen business. New share. Oops. See, it's not here. One sec, I'll get it for you now. Let me just find it now. Sorry, guys. Oops. Okay, my computer is battling here. I don't know, it's froze. Oops. Okay, the next one. Oh, I see why. Okay, I think I got it. The memo. New share, memo share. All right. Okay, the memo. They've got increase in between A and B, the reaction increases. There's 1 mark for that. The reaction is exothermic, resulting in an increase in temperature. So they're saying there's an increase in temperature. I didn't say that. More molecules have enough kinetic energy, more effective collisions per unit time, or more. Yeah, you must say per unit time. I think it's better, nah? More effective collisions per second. That's what we'll say. Okay, so that's how they gave the 4 marks. So just say that you must say these things. You can say the reaction will increase. The reaction is exothermic. There's an increase in temperature. The more particles have enough kinetic energy, more effective collisions per second. 4 things to write down. Increase in temperature. More molecules have enough kinetic energy, more effective collisions per second. Okay, and why does it decrease between T2 and T3? The reaction decreases. Why does it decrease? They've got it decreases because the concentration of the acid decreases, or it decreases is 1 mark, and you must write one other thing. The surface area of the magnesium decreases, the reactants are being used up. So I said it decreases because the reactants are being used up. All right, so that's the answer that I've given. So that will be acceptable as well. Okay. Let's take the next one. Next question. In another experiment, they add 5 grams of magnesium to 30 centimeters cube of dilute hydrochloric acid of concentration 1,5 mole per dm cube. They obtain graph T below. The graph is not drawn to scale. Okay, graph T. Graph S is our original. So graph T is on the left-hand side of graph S. Now, what does that mean? If you look at this graph, before we even look at the question, if the graph T is on the left-hand side of graph F, we'll see that the reaction completes earlier. Nah? That's where that reaction completes. Our original reaction in S completes there. That means it's a more vigorous reaction. The reaction takes place faster. Nah? So it's a reaction that takes place faster. So as a result, there must be a reason for that. Why does the reaction take place faster? So if you look at it, T will be a more vigorous reaction. It takes place faster. It reaches, the reaction completes quicker, earlier, because give 2 reasons why graph T differs from graph F. Why will it complete earlier? It will complete earlier possibly because the temperature is higher, the concentration of the acid is higher. Well, let's see our results. What did our original one have? 30 centimeters cube hydrochloric acid concentration 1,5 mole per dm cube. 1,5. So the concentration is the same. We'll have to look at temperature. You can use look at surface area. You can look at catalyst. All right. So those are the things that you look at. So one of the answers will be temperature is higher. It took place at a higher temperature. Can't get the memo. Let's just get this memo. One sec. Right. Any of the 2 answers? Higher temperature. The temperature of the reaction vessel was higher. We mentioned that. The larger surface area, or the magnesium was crushed into a finer powder. We've mentioned larger surface area, or addition of a catalyst. All right. So those will be the answers that are acceptable in doing the sum. Okay, so out of 15, how did you fare? If you evaluate, how did you do? All right, so Those will be the way of answers that we are looking at, and that will be the completion of the sum.